Hello everyone, myself Rupalakshmi K. In this video, we'll be discussing on an artificial intelligence and machine learning project, wine quality prediction. My teammates are Pratibha, Sarita, and Soumya. These are the contents discussed in the video. For this project, we have used Kaggle's red wine quality dataset to build various classification models to predict whether a particular red wine is good quality or not. Each wine in this dataset is given a quality score between 0 and 10. For the purpose of this project, we converted the output to a binary output where each wine is either good quality, a score range of 7 or higher, or not, a score below 7. The quality of the wine is determined by 11 input variables. The input variables are fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfides, and alcohol. Before going into the project, let's brief on what is AIML. AIML stands for Artificial Intelligence Markup Language. It is an XML dialect for creating natural language software agents, particularly chatbots. AIML was developed in the late 1990s by Richard S. Wallace and his company Pando Robots, and it has gained popularity as the markup language used to create chatboxes for various applications including customer service, entertainment, and education. AIML uses pattern matching techniques to generate responses to user inputs. Chatbot developers create AIML files containing patterns and corresponding responses which the chatbox uses to understand and respond to the user queries or statements. AIML supports the creation of conversational agents with varying degrees of complexity, from simple rule-based systems to more sophisticated ones, incorporating machine learning and natural language processing techniques. The objective of this project is to experiment with different classification methods to see which yields the highest accuracy and to determine which features are the most indicative of a good wine quality. A model selection refers to the process of choosing the most appropriate machine learning or statistical method for a particular problem or dataset. In the context of predictive modeling, model selection involves evaluating and comparing different algorithms or methods to determine which one performs best for the given task. The process of choosing an appropriate machine learning model for wine quality prediction are random forest, XGBoost, KNN, logistic regression, SPC, decision tree, and Gaussian NB. Random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of classes or mean prediction of individual trees. Random forest code used in this project is given. This code demonstrates the use of random forest classifier from the scikit-learn library in Python. First, the random forest classifier class is imported, then an instance of the model is created with a specified random state. The model is then trained on the training data and using the fit method. After training, predictions are made on the test data using the predict method, and the predicted values are stored in the ypredict2. Finally, the accuracy of the model's prediction is calculated using accuracy score function from the scikit-learn's matrix module, and the result is printed on the console.
This is Pratibha. I will be discussing two models. They are XGBoost and KNN. Now let's see the extreme gradient boosting. It is a scalable and efficient machine learning algorithm that uses gradient boosting framework to produce accurate predictions by sequentially combining weak learners. This is the code of extreme gradient boosting. The code employs the XGBoost library, a popular tool for gradient boosting. To build a classification model, initially it imports the necessary library and initializes an XGBoost classifier model with a random seed set of reproducibility. Then the models is trained on the provided training data and labels. Following the training phase, predictions are made on the test dataset using the trained model. Subsequently, the code imports the accuracy score function from the scikit-learn library to evaluate the performance of the model. Finally, it computes and prints the accuracy score, which indicates the proposition of currently predicted labels in the test dataset. K-nearest neighbors. It is a supervised machine learning algorithm that assigns a class label to a data point based on the majority class of its nearest neighbors in the future space. KNN code used in this project. The provided code snippet utilizes the K-nearest neighbors algorithm for classification. It imports the KN neighbors classifier class from the scikit-learn neighbors module and initializes a KNN classifier named model with a parameter n underscore neighbor equal to 3, indicating it will consider the labels for the three nearest neighbors when making predictions. The model is then trained on the provided training data and used to predict label for the test data. Subsequently, it imports the accuracy score function from the scikit-learn matrix module to calculate the accuracy of the predictions by comparing them with the true labels. The accuracy score is then printed to evaluate the performance of the KNN classifier.
Hello everyone, myself Sarita. I am going to discuss on two models, that is logistic regression and SVC model, which are used in our project, that is find quality prediction. So firstly, logistic regression. Logistic regression is a statistical method used for binary classification, estimating the probability that a given input belongs to one of two classes based on its features. Logistic regression code which we have used in our project is this one. This code snippet performs the following task. The, Firstly, it imports the logistic regression class from the sklearn.learn model module. Next, it initializes a logistic regression model named model. Next, it fits the logistic regression model on the training data, that is X-train and Y-train, where X-train represents the feature matrix and Y-train represents the target labels. Next, it predicts the label Y predict for the test data X text using the trained logistic regression model. Next, it imports the accuracy score and confusion matrix functions from the sklearn.matrix module. Nextly, it calculates and prints the accuracy score of the prediction by comparing them with the true label Y test using accuracy score function. Lastly, it prints the confusion matrix, which is a table that summarizes the performance of a classification model, showing the number of true positive, true negative, false positive, and false negative prediction. In summary, this code snippet, which is provided in our project, demonstrates how a logistic regression model on a given dataset make predictions using the trained model and evaluates its performance using accuracy score and confusion matrix. Next is SVC model. Support vector classification is a supervised machine learning algorithm used for classification tasks, which constructs a hyperlane or set of hyperlanes in a high dimensional space to separate data points into different classes. So this is the code snippet which we have used in our project that represents the sklearn model. So this code snippet, it firstly imports the SVC class from the sklearn.svm model to create an SVC model, and the accuracy score function from the sklearn.metrics module to evaluate the model's performance. Next, it initializes an SVC model named model with default parameters and fits the model to the training data, that is Xtrain and Ytrain, using the fit method. Here, Xtrain represents the features and Ytrain represents the target labels. After training, the model predicts the labels for the test data, Xtext, using the predict method, and the predicted labels are stored in the variable predict_y. The code then calculates the accuracy score of the model's prediction by comparing them with the true labels, that is y-test, using the accuracy score function. This score represents the proportion of correctly predicted labels in the test sets. Finally, the accuracy score is printed to provide an evaluation matrix indicating how well the SVC model performs on the test data. So this was all about the SVC model and the regression model, which we have used in our project for the demonstration of the quality of file prediction.
Hello everyone, this is Soumya A. Bavagi, pursuing my engineering in Sri Venkateswara College of Engineering, Bengaluru. My topic is decision tree here. A decision tree is a supervised machine learning algorithm that recursively partitions that input space into the regions, assembling a label to each region based on the majority classes of training samples within that region. Decision tree is used in this project. So here is some code which we used in our mini project for this time. So let me explain what is decision tree. Is that the provided code uses a decision tree classifier for a classification task. It imports the decision tree classifier, that is the class, from the scheme.tree module and initializer decision tree model. Basically, it will classify and also it will distinguish the particular tree here. And also talking about the model is configured to use the entropy criteria for splitting and sets for a random seed for pre-productivity. Following initialization, the model is trained on the provided training data. Once trained, the model predicts the labels for that particular test data. So it imports the assurity score function from the scheme to module to calculate the accuracy of the module's predictions. By comparing them the true tables, the accuracy score is then printed to assess the performance of the decision tree classifier and classifying the test class. Alright, so the next topic is Gaussian naive basis. Is a supervised machine learning. It is one of the machine learning algorithm based on the Bayes theorem, assuming that the features follow a Gaussian distribution. Here used for the classification task, there is a code. For the code, I'm going to explain what it is. Provided code is the Gaussian naive basis. First, what it does is it first imports the Gaussian NP class from the module and initializes a Gaussian navel and based model. The model is then trained on the provided training data. Once trained, the model predicts the labels for the test data as well as the function from the scheme.matrix module to compute the accuracy of the model's predictions by comparing them. The true labels finally assure the score is printed on the evaluated performance of the Gaussian classifier and classifying the test data. Alright, let us see how the code works for the complete mini projects. I'll be showing you the code in next few seconds. Moving on to the conclusion part, the use of the predictive modeling techniques such as decision tree, Gaussian Nave Bayes, and other discussed in this analysis hold the immense significance within the wine industry. By leveraging these algorithms, winemakers can enhance the various aspects of wine production and also the distribution, ultimately improving the quality and marketability of their products. Predictive modeling enables the winemakers to gain deeper insights within the complex interplay of factors influencing with wine quality, such as acidity levels, sugar content, and alcohol concentration. By analyzing the historical data and employing the machine learning algorithms, they can accurately predict wine quality based on these factors, facilitating more informed decision making throughout the production process. Furthermore, application of the predictive modeling techniques extends beyond the quality prediction. So, in conclusion, the integration of the predictive modeling in the wine production improves the winemakers to make data-driven decisions, optimize the production process, and better connection with the customers. By harnessing the power of enhanced analytics, the wine industry can continue to innovate a thread increasing competitive market landscape. Thank you.